The solar intensity at the position of the Earth is 1,380 watts per meter squared. So per meter, per square meter, 1 meter by 1 meter, every second we have 1,380 joules per second hitting a square meter. State why an average value of albedo is quoted. It says the average albedo of the Earth is minus 0.3. Now the albedo from this over here is the total scattered power over the total incident power. Now we know that on the Earth you've got different surfaces. You've got different surfaces with different absorption and reflective values, and so obviously you're going to need to get a average value. Now it says show that the average reflected intensity from the Earth is about 100 watts per meter squared. Now to understand this, you've got to think about firstly with the absorption. Now, if you've got the sun here, let me maybe draw it over here. See if I can explain this. You've got the sun over there, and it's radiating energy out in 3 dimensions, and then you've got perhaps the Earth over there, and it's absorbing some of the energy. Now, can you see that the light coming in here, if I just draw this in, is the light coming in will be this light here, and it will actually, from looking at it from this direction, you actually have the area that it's going onto is a circle, and that area is equal to pi r squared. But that energy going on to that circle is actually spread over the whole sphere, and the surface area of the sphere is equal to 4 pi r squared. So in actual fact, per meter squared on the Earth is not going to be 1380, but it's actually going to be this ratio. We're going to have pi r squared divided by 4 pi r squared, because that's what it's actually distributed over, times 1380. So these cancel out. We actually get a quarter really of it, and that's the energy per meter squared on the Earth's surface that's actually coming in. Now the albedo we are given is equal to 0.3, and we're looking at the scattered power. So this is what I'm looking over here. I want the total scattered, the reflected intensity. So let me just put here reflected here. So it's going to actually be that value times that. And when I do that, I get about 102 watts per meter to the minus 2. So it's roughly equal to be about 100 watts per meter squared. Okay. I hope I made that reasonably clear. If you want further explanation, I'll be happy to help you with that. The last question here, one of the expected results of global warming is an increased sea level. The increase in the change in volume for temperature increase delta T is given by this formula. Show using the following data that the resulting rise in sea level is about 0.5 meters. So we have here our change in volume is equal to our constant here. That's the constant of coefficient of expansion times our volume times our change in temperature. So that's going to be 8.8 times 10 to the negative 5 times by the volume. Now, we're not actually told exactly what the volume, but we're told the surface area and the ocean depth. Now, obviously, if we multiply these two things together, we're going to get our volume. But I'm going to put this, we want our answer to come out in meters, so I can convert it now into meters, or I can convert it later into meters. Let's keep it in kilometers now, and we can come back when we come back, because if I multiply, this is going to get 3.6 times 10 to the 8 times 10 to the 8 kilometers squared times 3. So I'm going to get a kilometers cubed times 2. That's going to be my change in V. So if I multiply that all out, I get, let me just do that actually. So I'm going to get 8.8 exponent minus 5 times 3.6 exponent 8 times 3 times 2. And I get this value over here, that my change in volume is equal to 190080, and that will be kilometers cubed. Now, that increase in volume is going to be spread right the way across the whole surface area of the ocean. So we're going to, if I divide this, my change in volume, by the surface area, I should get a height increase. So my change in height will equal this 190080 divided by 3.6 times 10 to the 8. So if I divide that by 3.6 exponent 8, I get 5.28 times 10 to the negative 4, but that will be kilometers. Now we know that there are 1,000 meters in a kilometer, so this is going to be 5,280 meters times 10 to the negative 4, or about 0.5 meters.